everybody to day two of the conference where we have our more senior scholars reflecting on interactivism in various ways. Our opening speaker is going to be Richard Campbell, and after Richard's talk is over, we're going to open things up to questions to the audience and hopefully have some discussion. We'll then take a quick break, have two more talks, and then go for lunch/dinner.
Okay, now I'm relieved, Jet. Now I understand the Mr. Georgi, because it was referring to seniority.
It might be a Turkish thing. I start calling people Mr. now.
Bey Georgi, or?
Exactly, Georgi Bey.
Georgi Bey, okay. Tamam.
All right, Richard, I think you should be able to share screen if we've made you co-host.
Right. Well, just before I start, I want to thank the organising committee for inviting me to participate in this celebration of Mark's contribution to the psychology of the whole person, for it gives me an opportunity to acknowledge publicly how much I've learned from him, for which I'm so grateful. In my judgment, he's the most profound philosopher alive. But on top of that, it's been a privilege to become friends with such an extraordinarily good and generous man. So, a process-based understanding of causation and emergence. One of the crucial issues underlying the whole interactivist program has not, to my knowledge, been much discussed. It assumes an understanding of causation which is at odds with the prevailing neo-Humean understanding, which prevails in contemporary analytic philosophy. The very concept of interaction presupposes that something acts upon something else to bring about some change. But as Nicholas Capaldi pointed out in 1991, the denial of agency is one of the three identifying features of analytic philosophy. That's not surprising, for the current orthodoxy amongst philosophers, at least in my part of the world, is a reductive form of metaphysics that goes by the name of physicalism. However, a small but growing number of philosophers dispute the adequacy of that understanding of causation. They argue instead for a revival of the concept of powers, which was discredited and rejected in the 17th century. If the concept of powers is once again to be taken seriously, it must be shown why and how objects have powers. That's the challenge I will address in this presentation. In the first part of my talk, I'll discuss a recent book in which it's argued that powers are required to make sense of the success of reductive explanation in much of current science. In the second part, I shall then argue that although that analysis of reductive explanation is plausible, its extension to causation in general is deficient, precisely because it remains focused on objects. I will argue that causation has to be understood to be grounded in processes, and that because objects are constituted by processes, that causation can be attributed to them, and that there is genuine ontological emergence. One of my many disagreements with so much of contemporary analytic philosophy is its lack of any sense of history. For we cannot understand the questions we're trying to answer unless we understand how they've arisen. That's true of the issue of causation. So in order to show why it is now time to reconsider the nature of causation, a few historical remarks are in order. By the dawn of the 17th century, the very possibility of attaining the kind of knowledge the medievals called scientia, that's knowledge of necessary truths describing the essences of substances, had become seriously problematic. The synthesis of Christian theology and Aristotelian metaphysics, forged in the 13th century, was disintegrating. It was to establish the possibility of scientia on a new basis that Descartes wrote his Meditations. It's in the first sentence. Since he had argued that the essence of matter is extension, all physics needs is geometry. Therefore, he declared, final causes are useless in physics. Expunging from physics the notion that things act to achieve ends also rendered the notion of powers otiose, since they too were supposed to have intrinsic objectives. Talk of powers had literally been laughed off the stage. That's why it's so startling that a burgeoning number of philosophers are now advocating that such talk not only can, but must be revived. Those advocates will have to present a very strong case if they're to convince those philosophers who regard themselves as hard-headed empiricists, lest they invoke the same scoffing rhetoric to dismiss this renewed advocacy as a retreat to occult and unobservable entities which have no place in modern science. Given Descartes' dismissal of final causes and Locke's insistence that we have no knowledge of the real essences of things, David Hume relabeled efficient causes as secret powers, remarking, "We always presume when we see like sensible qualities that they have like secret powers and expect that effects similar to those we've experienced will follow from them." He proposed that that expectation is all there is to our idea of science, of cause, and that there's nothing in reality to justify that idea other than the fact that objects similar to what we call the cause are always followed by objects similar to what we call the effect. Contemporary debates about causation uncritically follow John Stuart's Mill and convert Hume's account of causation as constant conjunction into statements of necessary and sufficient conditions. That historical summary shows that the first step in the case for reviving powers must be to rebuke this neo-Humean understanding of causation. I observe, first of all, that the consequent discussion of causation has become bogged down in inconclusive debates about a variety of questions. Is causation a binary relation between a cause and effect? Or does it also involve other relata? Are causes objects, or events, or facts, or states of affairs, or situations, or something else? And how are causes individuated? Do they have to be defined relative to some comparison or contrast? Can absences count as causes? Is causation transitive? The list of problematic issues seems endless. I surmise that these philosophical debates are so inconclusive because they critically presuppose something like the neo-Humean understanding of causation. It's becoming increasingly clear that that presupposition is simply false. Strict regularities of phenomena are rarely observed, as Nancy Cartwright in particular has repeatedly pointed out. There are almost always exceptions because few observable phenomena are so isolated that their occurrence can be attributed to just one influence. What actually occurs is always the resultant of more than one influence being exerted in some region, because gravity, for example, is universal. Likewise, the operation of natural laws is regularly subject to interference by other influences. Even Newton's law of universal gravitation doesn't describe what we always observe, because we've all seen stones being thrown upwards and birds and aeroplanes flying. Manifestly, the universality of natural laws has to be explained differently. A more sophisticated way of explaining natural laws is to say they describe the dispositions of things to manifest certain properties and behavior when the conditions are appropriate, such as solubility. But because dispositions, like powers, are not always manifest, Humeans insist they must be reducible to non-dispositional properties. But that insistence generates the same problems as the Humean interpretation of natural laws. Identifying those deficiencies is what's led a small number of philosophers to challenge the whole neo-Humean understanding of causation. In the 1970s, Rob Harry published a couple of articles and a book on causal powers, but they were largely ignored. However, over the past 20 years, some philosophers began to argue that in order to account both for causality in general and for the explanatory function which laws serve in natural sciences, the concept of powers needs to be taken seriously again. The book I propose to discuss is Richard Corrie's Power and Influence, published in 2019, for he presents the most carefully worked out alternative to the neo-Humean understanding of reductive explanation. Noting that the reductive method of explanation has achieved remarkable success in many scientific contexts, he devotes the first half of his book to a meticulous analysis of it. That account provides the next positive step in the case I'm arguing. It'd take too long to report his analysis in detail, but it's relevant to mention its most salient points. Typically, reductive explanations are causal explanations, explaining the behavior of a whole in terms of causal interactions between its parts. Because this method works by identifying all those objects which, in the conditions prevailing, have influenced the production of that phenomenon, the first step in his analysis is to introduce the notion of basic objects. He says an object is basic with respect to an attempt at reductive explanation if and only if the explanation treats these objects as having no parts. That is, objects are basic relative to some attempt at explanation. He says they're, quote, not necessarily fundamental atoms, but may themselves be complex entities like planets, people, or breeding pairs. He then observes that all attempts at reductive explanation assume the existence of something that plays the same explanatory role, but this role cannot be fulfilled by anything in the standard ontologies. They all involve a new kind of entity, which he calls a causal influence. Because the reductive method is most spectacularly successful in the context of fundamental physics, there's good reason to think the causal influences are a fundamental part of reality. To complement that addition to the sparse world allowed by the Humeans, Corrie argues it's necessary to distinguish carefully three different but related factors: powers, influences, and changes. Powers are dispositions to exert influences. The manifestation of a power is not typically a change in some property, but rather the existence of a causal influence which makes a contribution to such a change. Influences combine to produce a change in the state of a system. Defining powers in this way enables this analysis to accommodate the fact that what happens is almost always the result of the interaction of multiple influences. Corrie then defines basic powers as a set of causal powers such that each power is distinct and that all influences that are relevant for the phenomenon are manifestation of powers in the set. Arguing that while some dispositions can be properly described by singular subjunctive conditionals, powers are best represented, he says, by mathematical functions rather than by singular subjunctive conditionals. He then defines the explanatory basis for some phenomenon P as a set of basic objects together with a set of basic powers for P, such that each power in the set can be represented by a function whose domain in the state space of some subsystem of those basic objects. He then argues the following 5 assumptions underlie any attempt to provide a reductive explanation of some phenomenon P in a complex system S. They are: 1, supervenience. There's a set of basic objects such that the relevant properties of that phenomenon supervene on the properties of and the relations between these basic objects. 2, limited rank. There's an explanatory basis for P in S which doesn't include any basic powers that have a rank higher than the highest rank causal power in the explanatory basis being used, where the rank n is assigned to a power just in case that n basic entities are required to determine whether and in what manner that power is manifest. 3, changes determined by influence. The changes in any property of a basic object at any time are determined by a set of all and only the basic influences, which are individually directed towards changes in that phenomenon, in that object at that time. 4, algebra of composition. In cases where there are more than 2 influences operating at the same time, we construct a rule which relates each pair of influences to a third resultant influence, and that composition rule can be used to calculate the resultant of any number of influences. And 5, influence characterized by effect. Causal influences are uniquely characterized by the effect which they can bring about if they were acting in isolation. There is 5 assumptions. Corey illustrates his definitions and principles by a wide variety of examples, from electrons to the ecology of populations. He shows how this account can accommodate a probability distribution over possibly manifested influences, so it's not necessarily deterministic. It's also able to accommodate the fact that, outside fundamental physics, it's likely that many, if not all, the powers and influences are composite rather than fundamental. And he argues successfully both that macroscopic powers can be composed of more fundamental powers, and that it's possible there are some truly fundamental high-rank powers. Since reductive explanations typically explain phenomena in terms of the behavior of lower-level objects, I find this analysis convincing and commend it for your consideration. Both the widespread success of applying this method in the various sciences and the universality of natural laws requires that this threefold model of powers, their manifestations as causal influences, and the observable changes these influences produce, typically in combination. Another reason for commending his analysis is that it enables a clear definition of physicalism. Although many philosophers subscribe to this doctrine, no one to date has been able to give a clear account of what exactly it's claiming, as Daniel Stolzer has demonstrated. Since physicalism is a reductive view, I offer the following as a definition: that all the things which exist in the universe either are or are composed of parts which are the particular objects found by physics to be fundamental, in the sense that, in principle, the behavior of them all is entirely explicable in terms of the properties and relations of those ultimate parts. It's understandable why so many analytic philosophers adopted this position. Most of them write in a Western language, which prioritizes nouns over verbs. They accept the system of predicate logic introduced over a century ago by Frege and Russell, in which quantifiers range over domains of particular objects. They're also heirs to a metaphysical tradition, which for nearly 2.5 millennia has assumed that the primary category of being is what Aristotle called ousia, a word I think is best translated as entity. Well, the medieval philosophers called it substantia, and analytic philosophers often today call objects or basic particulars. Moving on to the third step of the case I'm presenting, Corey himself argues that there's a flip side to this analysis. He claims that, quote, there's a close connection between the concept of emergence and the failure of reductive explanation. That is, emergence occurs, quote, in situations in which the assumption of supervenience holds, but reductive explanation fails. He claims that the existence of higher rank powers limits the capacity of the second assumption, and that the fourth assumption, the algebra of composition, fails in complex cases. Those failures show there exist phenomena which may legitimately be regarded as genuine cases of ontological emergence. Moreover, he rebuts 3 arguments mounted by Jaegwon Kim's objecting to the very possibility of an emergence. Unfortunately, I don't have enough time to discuss Corey's arguments about emergence here. I simply commend his book for you to assess their cogency yourselves. The fourth step in my case is to broaden this analysis so it applies to causation in general, which Corey attempts to do in chapters 8 and 9 of his book. He denies that causation can be simply identified with influence on the grounds that causation is an abstract relation, while causal influences are entities as real as tables, electrons, and electromagnetic fields. However, in a discussion of intuitions around causation as production, he considers a basic influence I, that is, an influence which is the manifestation of a single basic power, which is directed towards changes in some particular property of some basic object X. He asserts that, quote, there will be a power P which belongs in part of some system, which includes X, will be part of some system which includes that object, such that the system's being in the state S triggers the causal power P to manifest the influence I. It makes perfect sense to regard S as a productive cause of the change in the change in X, unquote. So it seems that he's identifying the cause of a change as the state of a system, although he also comments that the influence I can be regarded as a physical embodiment of the causal relation. He recognized what he calls a connection of directness between cause and effect. But to explain it, he draws on the account of causation just given. I find this account of disappointing. Although the notions of a power and an influence are notions of something dynamic, the notion of the state of a system certainly is not. Corey had introduced a system as a collection of basic objects together with all their properties and relations. So according to his account of causation, a cause is a set of objects. Of course, objects and persons are often identified as the cause of some occurrence, but so are items in many other categories. What I miss is any account which explicates what is common to all these different kinds of cause. Now, Corey is aware that there's a serious problem in attributing powers to fundamental objects or sets of objects. For in the final section of chapter 3, He comments that if reality were as described by classical, that is Newtonian physics, it would be very tempting to suppose that the most basic influences are the fundamental forces, and that these are indeed sui generis constituents of reality. However, since quantum field theory, hereafter I'll call that QFT, has displaced Newtonian physics as our best description of the fundamental nature of the world, Corey notes that one might be worried that it actually contradicts the arguments he's given. His response, however, is simply to note that the fundamental forces are commonly described as constituted by the exchange of elementary subatomic particles, and commenting that, quote, even if it's true that forces are constituted by the exchange of particles, these, quote, particles are not like the objects that are found in standard ontologies, for QFT tells us that subatomic particles can also be viewed as field excitations, and unlike ordinary particles, these field excitations can be added together or superposed in a similar way to forces, end quote. Well, QFT challenges one of the bedrock assumptions of Western metaphysics. But instead of engaging with that issue, Corey comments, for the moment then, the fundamental ontology of forces and hence influences in general remains unresolved. He suggests that it's possible that the most basic influences might be constituted from more fundamental ingredients which are not themselves influences. In that case, the reductive method would not be applicable at the fundamental level. Or influences might be a fundamental part of reality, in which case he says it's likely that the fundamental influences include the fundamental forces. I find it disappointing that by formulating those two possibilities in terms of influences, he sidestepped the challenge which he himself has recognized. The QFT appears to contradict the assumption at the heart of his arguments, that influences are the manifestation of powers, and powers are dispositional properties of objects. By not addressing that challenge, he's left the plausibility of his whole account as a hostage to fortune. I was surprised to find this deficiency in Corey's analysis, since I find it to be a plausible and illuminating analysis of reductive explanation, which does deal with objects. While I do not pretend to have sufficient expertise to unravel all of the notorious difficulties generated by quantum physics, I do have some thoughts to share concerning the challenge posed by QFT, which will provide the fifth step in the case I'm presenting. Corey offers one remark on the two possibilities he just articulated. He tells his readers that, note that fundamental influences need not be forces, unquote. He justifies that claim by citing the four-dimensionalist view of the universe and pointing out that a natural way to make sense of that interpretation of space-time is to propose that a three-dimensional object at a given time produces an influence directed toward the existence of a similar three-dimensional object at a later time. Many analytic philosophers are predisposed to adopt such a four-dimensional interpretation of the universe as a block because they inconsistently combine their professed empiricism with an understanding of logic that assumes the truth is timeless, a conception of truth inherited from Plato. But that interpretation of the universe in which we live is simply incredible. The universe is full of movement and is populated by living creatures who exist by performing future-related actions. Not only that, but also the spatializing of time involved in that four-dimensional interpretation of the universe is inconsistent with the general theory of relativity, which has been confirmed over the past 100 years by increasingly fine-tuned astronomical observations. As the theoretical physicist Carlo Rovelli has pointed out, at the core of general relativity is a radical relationism. There are no independent background framework of space-time within which three-dimensional objects could be located. Spatio-temporal locations can be distinguished only relative to other spatio-temporal locations. So the argument which Corey invokes to support his claim that fundamental influences need not be forces is not sustainable. When quantum physics first emerged early in the 20th century, it had two features which generated deep puzzlement and debate. The phenomenon seemed to manifest both wave-like and particle-like features. The famous two-slit experiment seemed to show that photons are waves, whereas single spots on a photographic plate and tracks in a bubble chamber and clicks on a Geiger counter all seem to show that photons are particles. That apparent contradiction was essentially resolved by Paul Dirac, who proposed an interpretation of relativity theory in which these subatomic phenomena are explained by quantizing Maxwell's electromagnetic field. And Dirac then extended that analysis to apply also to electrons, and further refinements have been made to QFT since. Those phenomena were puzzling enough. But even more puzzling was a principle which Werner Heisenberg proposed in 1927. It seemed that a quantum, quote, particle, such as a photon or an electron, can be described by a wave function which specifies the evolving probabilities of its possible trajectories. But so long as it's not measured, it has neither a determinate location nor a determinate momentum, but not both. Sorry, I skipped a line. Nor a determinate momentum. Yet when such a particle is detected, either its location or its momentum becomes determinate, but not both. This strange phenomenon came to be called the collapse of the wave function. Initially, this so-called collapse was understood to be a fact about observation, but that was a mistake. The so-called collapse of the wave function happens whenever a quantum system interacts with any other one. Also, in the early decades of quantum physics, many physicists advocated a theory in which fields and particles were both acknowledged as associated. But over the past 40 years, leading quantum field theorists have developed a pure field view. The physicist Art Hobson published a representative exposition of this view in 2013 under the title, "There are no particles, there are only fields," explaining how a quantum field fluctuates back and forth like a harmonic oscillator. He asserts that even a quantum field, which is in the so-called ground state of a space devoid of all the so-called elementary particles, cannot sit still because of the so-called uncertainty principle. So he comments that, quote, "An important feature of QFT is the existence of a vacuum state, which manifests itself experimentally in many ways, which would be curious if particles were really fundamental, because there are no particles or quanta in this state." He observes that some authors conclude incorrectly that the countability of quanta implies a particle interpretation of the quantized system. Discreteness is a necessary but not a sufficient condition for particles. Quanta are countable, but they're spatially extended and are certainly not particles, unquote. Not surprisingly, Hobson's thesis attracted objections from a number of physicists who argued that quantum fields are no more fields than quantum particles are particles. And in addition to there being no particles, they're not even fields. They insist the state of a quantum system is an abstraction. Hobson rebutted the technical objections which were posed by his critics, which I can't go into here, But on the issue of the reality of fields, he replied simply that there's no reason to regard quantum fields as less real than rocks. Indeed, rocks are made of them. It appears from my reading that the debate between the realist and the instrumentalist interpretations of quantum field theory continues to be a standoff. But I suggest there's a way of moving beyond it. I invoked above Ravelli's radically relational interpretation of general relativity. Since on his interpretation, there's no absolute viewpoint from which anything can be observed, he infers that in quantum mechanics, different observers may give different accounts of the same sequence of events. That leads Federico Lodisa and Ravelli himself to assert in an article in the Stanford Encyclopedia of Philosophy that the physical world must be described as a set of interacting components where there's no meaning to the state of the isolated system or the value of the variables of an isolated system. The state of a physical system is the set of the relations it entertains with the surrounding systems. Consequently, Ravelli argues that the wave function is merely a predictive instrumental device with no ontological role. It doesn't stand for something real, but simply records the probabilistic outcomes of previous interactions between systems of a certain kind. However, I share Hobson's realist intuitions. To say that all we can know at the quantum level are discrete events which occur when an observer interacts with such a system is one thing. To deny that anything real is happening in between such interactive events is something else. What is the it with which such an observer interacts? And if quantum fields are real only intermittently, how can rocks, which certainly are real, be made of them? In an extensive evaluation of Ravelli's relational quantum mechanics, Mauro Dorato notes that his relationist interpretation of quantum physics can be formulated in two different ways. Quote, either it does not make sense to talk about a quantum non-interacting system, or to put it more metaphysically, non-interacting quantum systems have no intrinsic properties, only dispositional ones. Ravelli doesn't describe quantum systems as having dispositional properties, but Dorato's introduction of them in this context is both insightful and brilliant. For that notion enables Ravelli's position to be interpreted in a way that I suggest is both coherent and satisfies the realist intuitions I endorsed above. For if the properties of such systems are dispositional, it becomes possible to acknowledge the reality of the wave function, even though whenever that disposition is isolated, its state is probabilistic and indeterminate. Furthermore, there's no need for such a disposition always to be manifest, for that's true of any disposition. Yet one of those probabilities can become determinate when the system interacts with another such system. Thus, it's possible to accommodate Heisenberg's so-called uncertainty principle without adopting a purely instrumentalist interpretation of it. Lodisa and Ravelli, in fact, commend Dorato's analysis as, quote, fitting particularly well in the context of relational quantum mechanics. Since dispositional properties are real, that endorsement should have led them to modify their earlier instrumentalist claims. Another question Dorato asks is, how can we identify the same sequence of events within a relationist view of quantum mechanics? He answers that stressing the relationality of the identity of process systems helps us to realize how the identity of a sequence of events, that is, the processes that characterize the primitive ontology of the theory is relative to the different observers. The argument he presents to support that contention is too technical to repeat here, but to skewer the next step in the case I'm building, it's enough to highlight that Ravelli must be referring to processes when he speaks of the same sequence of events. That makes it clear that the primitive ontology of QFT must consist not just of fields, but of fields which are always in process. Like harmonic oscillators, quantum fields are constantly in a state of excitation. Consequently, the so-called elementary particles are not particles at all. They are processual in nature. I propose that Dorato's interpretation dissolves the problem which ungrounded influences generated for Corey's account of influences. Once the processual nature of these vibrations in quantum fields is recognized, it becomes obvious that processes were already implicit in describing the so-called particles of QFT as excitations. This finding provides what I discern to be missing in Corey's account of causation. While he nominated basic objects as the bearers of powers in the case of reductive explanations, if influences are the manifestations of powers and powers are dispositional properties only of objects, then his case is undermined by the fact that the so-called subatomic quantum fields are always in process. But because they are dispositional in nature, it's processes which are the ultimate bearers of powers to manifest influences upon each other and upon higher level entities. It follows from QFT that all the standard ontologies are obsolete and must be either abandoned or radically revised. We've seen that the ambition of physicalists is to reduce everything to the particular objects found by physics to be fundamental, such that the behavior of everything is entirely explicable in terms of properties and powers of those ultimate parts. But if there are no basic particulars, the metaphysical assumption upon which physicalism is based is simply false. The irony of modern analytic philosophy is that its adoption of physicalism makes it appear to be state-of-the-art and scientifically literate, whereas in fact, the lingering hangover of an ancient metaphysical model is inconsistent with the findings of physics itself. Since quantum fields in process are the best candidates we have for what is fundamental in the universe, this finding has significance for the whole of metaphysics. As I argued in my 2015 book, The Metaphysics of Emergence, it's no longer tenable to promote metaphysical models which accord ontological priority to particular objects. What is needed to understand the world better is nothing less than a metaphysical revolution which reverses ontological priorities, so that the primary category of being is understood to be generic processes. In a metaphysical model based on processes, particular objects are emergent, not basic. Processes are a sui generis category, largely neglected by philosophers. While Whitehead is standardly classified as a process philosopher, he was unable to recognize the continuity of processes, perhaps in deference to the discoveries in the early days of quantum mechanics, for he wrote, "Continuity concerns what is potential, whereas actuality is incurably atomic."
Richard,
when we think about
Richard, we've hit our 45 minutes. Would you be able to wrap up with some concluding thoughts or?
Yeah, all right. You can read the rest of it. It's on the website. I'll read my concluding paragraph. Anyone who's having trouble understanding how macro objects emerge from the way in which their constituent processes have organized themselves needs only to reflect upon the fact that everything in the universe has some temperature. As we now know, heat is kinetic, that is, processual. We observe, for example, water evaporates. Lowering its temperature causes water to freeze into a solid block of ice, a phase change. We also observe that raising the temperature of water turns it from a liquid into steam, a different phase change. Furthermore, when water is heated, a primitive form of self-organization emerges, the formation of Bénard cells. Again, it's the kinetic nature of heat which produces the processes which constitutes Marx's paradigm of a process system that is self-maintenance, a candle flame. And while these are inorganic examples, living creatures appeared on this planet when certain process systems emerged that are recursively self-maintenance. I submit that once powers are understood as inherent in processes, the accusation that to speak of them is to admit of occult and unobservable entities into one's ontology is quite baseless. The fact that processes exert observable influences on what happens is no more mysterious or secret than the fact that while we cannot observe the wind, we regularly see and feel its effects. Processes and their influences are everywhere around us and in us all the time, constituting the objects we see and enabling the emergence of life.
Great, thank you very much. So I think we can use our electronic hands. Perhaps that's the easiest way to do the questions. Itai, you're welcome to raise your issue that you posted in the chat, but you've been beat by a couple of quick draws. So we'll go first with Ken, if he wants to ask his question.
Sure, but I'm even more interested in Johannes. I'm more than sympathetic to your presentation, Mr. Campbell, and wish to mention a couple of things that are both historical and philosophical very briefly. One item you left out of the 13th century was 1277 Paris, Tempier, the thesis condemnation. That is what inserted deductivist infallibilism into philosophy. And Descartes' evil deceiver is just waiting in the wings of that.
I agree.
The other side of the history is that Newton had already demonstrated that gravity is a field and measured it pairwise across the solar system using independent measures that are extremely precise. And the empiricists have just got Newton wrong from day one. This comes out of work that runs from Howard Stein through Chandrasekhar up through Harper. And if you like, Harper's got a very new piece on the method that makes this work and how it's still used in cosmography today. I'll send it to you if you wish. The other is, there's a wonderful book by Stijn Brock on excuse me, I'm not remembering the whole title, but it's on QM and how by interpreting QM within the Helmholtzian methodological tradition, the realism comes right out in the wash. So let me just mention those, and I will send you a very brief list.
Thank you very much.
Could you send it to the whole list, Ken?
Sure. None of this is secret. I'm happy to publicize it. And I mean, I have when I can. But Newton's methods are just vastly more sophisticated than anything Hume could imagine.
Okay, great.
For that matter. End of comment.
Thank you very much for those. I'll look forward to reading them.
So we'll jump ahead to Johanna.
Good. Richard, wonderful talk. Thank you for bringing in Lots of issues, lots of fantastic observations. I want to first pick up perhaps on a remark that somebody made yesterday, somewhat flippantly, I think, that philosophy is science is all we need. I think what we see here is that all we need is probably at least philosophy of science and ontology. Philosophers of science may sometimes, as you also point out, be unawares of what it takes to characterize an entity, which presuppositions enter into talk about particles. So this is why we need a very, very careful ontological approach that is transparent to itself, that challenges its own presuppositions and so on. Okay, so I have a couple of remarks. The one, like Ken sort of just pointing out, there are, of course, some interesting process-based accounts of causation, partly by Wesley Salmon, but also more recently by, it's an Icelandic colleague, so Röngbaldur Ingtorsson. I will put that in the chat as well.
Thank you.
My main concern is about the suggestion that we can simply say something like the particles of quantum field theory are processes for the following reason. Quantum field theory uses space-time as a background theory. As you know, Rovelli has argued against that. There are strong arguments against just quantum field theory. This is why there is this new movement to develop theories that are called quantum gravity theories. And loop quantum gravity is Rovelli's preferred option. And the basic difficulty is to derive from non-spatial temporal properties of the fundamental posits there, spin networks, to derive from these spatial temporal properties, the functions at least of that which we need from general relativity theory. And there are constructions that supposedly can give us that. Lam-Wüthrich is here a pointer. But the difficulty is the following. It comes out in a very nice paper by Rovelli in the Foundations of Physics from 2019, where it's sort of beyond presentism and eternalism. Rovelli talks very quickly about the dynamics here, saying we need to think of a dynamics that is even before the sort of dynamics that we describe with space and time. So he makes use of the term dynamic in order to describe that which is foundational without explaining in any way whether we are entitled to that category feature. So what I want to point out is this: there has been, this is again goes back to a paper I published in 2002, Quantatropes and Processes, where I argued that when we talk about particles or quanta in quantum field theory, we really must be very careful. We must first get clear, what is a particular? What is an individual? What does it mean to be countable here? What would it mean to be dynamic in a field of posits that are before space and time? So this is, I think, where the discussion would need to start. And I have argued, for instance, that yes, quanta are processes, but probably processes not in a sense that most of you would recognize, but in the sense of processes that is the basic entity of a general process theory, so my own account. I think we cannot really make headway without collaboration. Sorry, this is a long comment. We need the collaboration here of physicists, philosophers of physics, and ontologists. To turn that into a question, let me ask you, what could it be? I mean, did you mean when you said we need to think the quanta of quantum field theory as processual? What is meant here? Did you mean that as a kind of primordial dynamics that we can think, as Rovelli wants us to, before that which we call dynamic within using a space-time framework as a background? Is it primordial to that? Is it that kind of dynamics, which it can't quite be if we want to go to loop quantum gravity of Rovelli's kind? So what is processual here?
Thank you for the comment. I can only give you a partial answer. What I had in mind when I said that, some of the bit that I had to skip towards the end, was the processes have direction, they have force, and they're future oriented. Though it was those three characteristics that I was picking out as relevant to explaining how causation is grounded in processes. I take it you're asking me, having characterized processes that, the quantum processes that way, is there something more fundamental than that? Is the citing Rovelli's talk of something before space and time in some sense. That's an issue that I just haven't gone into, but I'll certainly want to think about.
Okay.
Did you want to say something back, Joanna? Or is your hand up from before? Okay. So Itai, did you want to follow up, though you may be stealing time from the next speaker?
I wouldn't want to steal time from the next speaker, so in this particular occasion. It's up to you. Are we having a few minutes delay or?
So we have 3 minutes if we want to use them.
No. Well, yeah, it's not meant to be long. It's just a comment and a question, and the comment was already posted. I think we need to be careful in making such claims as there are no particles, right? It's not clear to me that the idea is that particles are excitation of quantum fields, and this is what it is, right? The field is the fundamental entity. But there's a difference between claiming that there is one fundamental entity and a host of entities which aren't fundamental, and the claim that there is, that if there are no particles, on what ground should we say that there are, there are planets, there are galaxies, there are trees, there are us? And that sort of existence monism that only allow for one kind of thing, is that a position that we want to end up with? So that's one thing. And the second thing was simply about, with all your critique of physicalism, I wonder, how would you characterize your position? And is that not some kind of physicalism too? I mean, I know what kind of view you're arguing against, but I don't think there is only one branch of physicalism. And in fact, if what many physicalism describe physicalism as attached to whatever science tells us, and your claim that science tells us something else, as long as you're not offering some alternative metaphysical ground that takes us in another terrain, why is it not just an alternative kind of physicalism?
Well, firstly, about your comment, I'm not wanting to claim there's only one kind of being in the world. And indeed, I've already argued that particular objects are themselves emerge from the interaction of processes. So there's two for a start. But of course, there are other ways in which we characterize things. Aristotle had 10 categories, and we might want to refine those, but it's no part of my claim that there's only one way of being. In fact, I argue in something else that I've written the contrary. As for the second point, it just muddies the water. Not to say, oh, I'm a physicalist, but I can't really tell you precisely what I mean by that. It's got something to do with physics being important. Of course, anyone who takes emergence as emerging out of the quantum phenomena that seems to be the best story physics can tell us at the moment, there is a sort of supervenience there, and why not acknowledge that? But I tried to give a much more precise account of physicalism because it seems to me the driving force between those philosophers who proudly wear the label is that they want to reduce everything to basic particles, and the use of the way the reduction works, and this is why I spent a bit of time trying to outline Corey's account. The way the reductive explanations work is it's in terms of parts. And as Joanna Sykes has pointed out, there's a fundamental difference between processes and objects, is that objects have parts, and something can be a part of another. A leg is part of a table. But processes can be part of other processes, but they don't have the mereological characteristics of multiple parts, separable and isolatable. And if you just content to use the word physical in a very loose and broad sense, I just don't think that helps us understand these rather difficult matters.
So we're a touch over, but we've built in small buffers into the lunch break and then our break. So perhaps we'll go with maybe one or possibly two more questions. Lucas, if you want to go ahead.
Yeah, can you hear me?
Yep.
Okay, sorry, because last time my microphone wasn't working. Yeah, so my internet went right at the end of the talk, so maybe someone asked this, or maybe you said something to clarify it. But I'm just wondering, you seem, in some sense, you quite like some of the idea in this book. But it seems to me, I'm just wondering whether you think you can really make sense of his idea of influence. So you said an influence is ultimately characterized by the effect they would bring about if there were no others. I guess if you're going to kind of be a dynamic field sort of person, that's never going to be the case. So I'm just wondering whether you can make any sense of this notion of an influence, like, and would you want to characterize it in that way? Or do you think there is some alternative way of characterizing? Yeah.
We have to have some terms, whatever explanation we give, we have to have some terms that we don't analyze. You can't analyze everything in terms of everything else. The point about acting in isolation was one of the 5 assumptions of a reductive explanation. That is, Corey's saying the way a reductive explanation works is by treating the system as the influence they would bring about if they were acting in isolation. But of course he knows very well that there isn't anything that acts purely in isolation. But he was suggesting, one of the assumptions of the methodology of giving a reductive explanation. I find it, we have to have some terms we take as basic, and causal influence is one that he is doing, explaining it by talking around it in terms of the productive factor of causes, the fact that changes are brought about by some forces, and so on. So you can kind of explicate what you mean by an influence. But I'm quite content to take it as a term basic for this analysis.
Mark, do you have a
It's fairly quick. Yeah, it's sort of a quick point, but maybe central in some ways. When we talk about quantum fields in effect being all there is as basic, or something like quantum fields, even if they're gravitational quantum fields, I have some quotes in mind that are rather interesting in that respect, but I'll skip those. We carry over entity intuitions. So we think of a quantum field as a thing, and we assume that there's some sort of monism because a quantum field is a thing. But the trouble is, quantum fields are not things. They are processual, whatever that means. And I grant that that in itself is a potentially problematic notion. But whatever else it means, or however else you account for it, they're processual, which among other things means they engage in various organizations of process. And everything there is in the world is not a quantum field per se, although I'm guilty of sometimes talking that way. It's an organization of process of quantum fields. And in terms of those organizations, you don't have anything like a monism. You've got an unbounded number of fundamental kinds of organization in quantum fields. You know, atoms and galaxies and rocks and trees and everything else, including ones we've probably never seen yet, but may come about tomorrow, or who knows. But the point is that carrying over our intuitions of substances or entities obscures the fact that quantum fields are intrinsically processual and therefore intrinsically organized, and organization is part of the metaphysics. It's not something over and above or on top of the metaphysics.
But this is exactly why it's better not to speak about particles do not exist, right? Because the point here seems to be that they are process organizations, as you said.
Well, particles in the classical sense absolutely don't exist.
All right.
These excitations don't have the properties that we use for particles. So when we say particles don't exist, we're not saying that we can't refer to anything by the use of the word particle. I mean, we can refer to things by the use of the word phlogiston, but phlogiston doesn't exist and particles don't exist.
Not in that sense, though we know what it is to refer to the grains of sand on the beach. The one thing I'd add to what Mark was saying is not only are processes organization, but they're also temporal. That was something I missed from Mark's comment. Because they're temporal, they exert a force. They're temporal and they have a momentum, and that's why they can express a force. That's why an influence is a causal influence.
Okay, so Johanna, sorry, maybe we'll save it to the break, because there will be a break. We can continue chatting, of course, then.